It's been a bit long time since I recorded my last video in this BladeTechTalk series, but finally I have some time now. And in this episode I want to talk about the frames again, but this time about the mounting standards and the build quality of frames for inline skates. So a frame looks like this, and it's needed to attach wheels to your boot of the skate. And there are two ways to do it. You can do it either permanently, which is usually done by attaching the frame to the boot with rivets, and that is usually done on either cheap recreational skates, some models of free skates, and in most of skates for kids. For example, here you can see the rivets that are not meant to be replaceable. So you can't really take off this frame and put another one. As soon as you choose some more advanced, more expensive skate, usually they have a boot and a frame that can be separated and replaced to whatever you want. Now there are two big categories of skate boots that define the mounting standards. One is a boot like this, where the bottom of the skate of the boot is flat. And these kinds of boots are mostly used for aggressive skating, where you spend most of your time either jumping or sliding on something, grinding. So you really want to be as low as possible to the surface to have the best control of equilibrium. And they usually come with frames that look like this. So they have very small wheels, flat surface that attaches directly to your boot. Then another class of boots are so-called free skate boots, but they are not necessarily for free skate, where heel is higher than the toes. So there is about 1 centimeter raise in the heel. And because of this raise of the heel, your natural position in such skates is a bit more leaned forward, and that is more comfortable for doing pushes during strides, when you go for long distance skating, for free skating, for speed skating. That is a more natural position that gives you a more comfortable way of making the strides. Now with this kind of boots, where the bottom is flat, there's only one standard that is widely adopted, which is called UFS. Now there are different kinds of frames in that standard. Most of them are like this, aggressive frames with very small wheels for being used in skate parks. But there are also other frames like this one, where the 2 points are still on the same level, but they are more for free skate, where you can put, for example, 80mm wheels here, but there are also other frames that support up to probably 125mm wheels. But they started appearing pretty recently, so there is not really a wide choice. Now, for this kind of boots, there is a much larger variety of frames, probably for historical reasons, but you can find all kinds of frames, either for speed skating, for downhill, for free skate, for slalom. There is much wider choice, at least right now. It can change in the future. But still, for this kind of boots, there are several different standards. So the most popular standard for free skate is 165mm, which you can see, for example, in this frame there is this raise for the heel, and 165mm stands for the distance between the two holes with which the frame is mounted to the boot. You can see, for example, here exactly these 2 points where the frame is mounted. Some more advanced boots have more options. For example, here, this is FR2 boot. It has a metal plate with many more holes where you can mount the frame. In particular, if you use the central points, they will correspond to 165mm distance. But if you take these points, they will correspond to 195 millimeter distance. And 195 millimeter is also a standard for mounting speed skating frames. I don't know exactly the reasoning behind that larger distance between the mounting points. I imagine it creates larger lever arms, so it reduces the chance that the frame will move during some really hard pushes. But then the same standard you can find in more specialized boots with low cuffs, specifically for speed skating, with that 195 millimeter mount. Now, so far, the standards that I've been talking about, UFS 165 millimeter and 195 millimeter, they are common in the sense that they are open standards, which means that anyone can create a new frame for that mounting standard and sell it without any issues. But there are a few proprietary standards. The most popular one is Trinity. It's developed by the Powerslide brand. Unfortunately, I don't have the frame here to show you, but its concept is that instead of having one mounting hole in the front, they have two mounting holes on the sides. And having those two mounting points on the sides instead of one in the front gives the advantage of avoiding this extra space needed for the screw between the wheels and the boot, which is specifically an issue with 3-skate frames. So by having 2 points here, the frame and the wheels can be put as close to the boot as possible. Another example of proprietary mount is Quattro mount from Adapt, where they also have 2 mounting points on the sides under the heel. So they have 2 here and 2 here, which in principle, the more points you have, the stronger is the connection between the frame and the boot, so there is less chance that it will get loose and be shifted during some tricks and jumps. But let's say a mount like this is the most easy to manufacture, because basically you have the surface, you make the holes, and you attach. If you want to make additional points on the sides, you need more material, and they are much more complicated in manufacturing. For completeness, I should mention that this Quattro mount from Adapt is pretty smart, because instead of giving just a big amount of holes like here, they made it compatible with 3 the most popular standards. So with their proprietary Quattro mount with 4 points, but it is also compatible with 165 millimeter mount, because they still have the holes in the center, and they are also compatible with the UFS mount, because it has exactly the same distance between the points except for the raise in the heel. And for that they sell just a spacer adapter that you can put under the heel. So technically you can also use, with a boot like this, a UFS frame like this. So if you put them, you have this space, but you can fill it with a 1 centimeter thick aluminum or plastic block, and you can still use it. So while technically you can of course use a UFS frame on a free-skate boot, or free-skate frame on a UFS boot by putting a spacer, it will work, but it's not ideal, because, okay, first of all, it will visually just not look as nice, and secondly, that's still an additional element that is not made of the same material, or is not exactly precisely manufactured for that combination. So it's not going to be as rigid. It is more likely to get loose with time. So if you want to change, you have to keep an eye on that element, the spacers, that you don't lose it. So a general user experience with that is worse. So the best solution, of course, is always to use consistently frame and a boot. So this is particularly important when you are choosing a skate or a boot, because you have to keep in mind what are the solutions on the market for other frames that you can use with this boot. For example, if you take this boot, it's a great boot, it's very supportive, it looks really nice, but it's UFS. So then depending on which style of skating you want to use it for, you have to check what frames are available for that. Because as I said, in UFS, most of the frames are for aggressive skating. If you want to do free skating, there is not such a large choice. Or for downhill, even less. For slalom, I don't know any frames that has a rocker ring deep enough for slalom skating, for example. Although I must admit that just conceptually, for slalom, having a UFS boot with being really very low to the ground seems like the best possible solution. But for historical reason, it's a 165mm mount that is the most widespread and is used for slalom, for downhill, for example, where you don't do any strides. So in principle, again, UFS standard would be beneficial for that. But so far, all frames for these activities come in 165mm standard, not in UFS. So I think with the mounting standard, it's pretty clear now. Let's talk about the build quality and design of the frames, because that is also a very important topic. So what would be the perfect skating frame? Well, first of all, it should be lightweight, it should be strong to not break, it should be cheap, and it should look nice. Well, the last one is subjective, so probably it's not possible to fit everyone. But at least the first three, so lightweight, strong, and cheap, are the most objective parameters. But as you can imagine, in a real world, this is not possible, so one has to compromise one of these properties. So the exact compromise you choose depends on the specific style of skating that you want to do with this frame. And each style of skating has its own priorities. So let's start with aggressive skating. For aggressive skating, you use very small wheels. You want to slide a lot, so your frame has to slide well. When you do big jumps, it has to withstand that impact and not break. And for that purpose, plastic works best. You can make it slide really well. Because wheels are small, it can be made pretty compact, so it doesn't weigh too much. And it's very cheap in production, so once you make a mold for that, you can mass produce them. Now for free skating, or downhill, or speed skating, also slalom, you're using noticeably larger wheels, usually starting from 80mm up to 125mm. And once you start using those wheels, there are additional forces acting on your frames that you have to take into account. And those forces, they make plastic pretty much unusable for free skating. So when you are skating a frame like this, and you want to do carving, or you want to make a stride and you push down at an angle, basically the pressure you create, it wants to bend these wheels like this. So it creates a lot of pressure in the walls of the frame. So you can imagine if with that large wheels you would have a plastic frame, it would be not rigid enough, it would just bend as soon as you make a stride and put a little pressure at an angle. It would break as soon as you make a jump, so it's practically unusable. Aluminium instead is still very lightweight, but it's much stiffer, it's much stronger, so it can take much more impact without breaking. And it's still fairly easy to manufacture. Now, aluminium also can be different. There are different grades of aluminium that have different level of rigidity. So the higher grade aluminium will be stronger, it will be less likely to bend or to break, but they are more difficult to process mechanically, so they are again more expensive. Then there are more exotic frames, for example, made of carbon fiber. It gives you advantage of being even more stiff than aluminium, but still being lighter. But the compromise with that is that they are much more difficult in manufacturing, especially for mass production. It's pretty much impossible. You have to do it almost by hand. So they are much more expensive than most of aluminium frames. So let's say aluminium is really the standard for free skate. It's cheap enough, strong enough, and light enough to cover most of the needs. But still there are details on how exactly you design your frame made of aluminium. Because remember, the first property of a perfect frame I mentioned was lightweight. And yes, aluminium is light, but still it's not weightless. So the less material there is, the lighter will be your frame, and as a result the whole setup. And in that aspect, some high-end speed skating frames probably are the most advanced, because they really use sophisticated computing simulations to find the optimal shape of the frame manufactured from a certain material, such that it provides the most strength with the minimum amount of material to make it as light as possible. When we are talking about more general use cases, so free skating, downhill, a slalom, where we don't really care that much about the weight, so we don't go to the extremes as in high-end speed skating frames. The easiest solution is something like this. So you have these continuous walls giving you the mechanical strength. When you put the wheels with the axles here, it will close the loop. So it fixes the distance here. You have the fixed distance on the top. So as a whole, it becomes a very mechanically strong construction. And I think the first brand that made this kind of design mainstream was Wizard Skating or Wizard frames, which have really thick walls without any holes, so they make very strong construction. Now, when you want to make your frame lighter, you start removing some material. For example, in this frame, you can see there are holes here. They've removed parts here. So when you have a wheel, like this is for 100mm wheels, it's easy to imagine that once you start skating it and you start leaning, curving, going on one wheel, this amount of material provides much less strength than something like this. But in this particular frame, for example, it's not compensated by anything. So it is by definition less strong than this frame. But in principle, you can compensate for that missing material in the walls by adding small bridges. For example, you can see it here. Instead of just removing completely aluminium, they've left a bridge here. There's also a small bridge here that adds a little bit more aluminium. So it's still a very light frame, but thanks to those bridges, it is much more strong than if you would remove them. The same you can see, for example, in this UFS frame. They've removed all the aluminium here, but then they've put a bridge. And even inside this bridge, they have a hole. So it's really very little amount of material, but it's still very strong. And considering that this is still for 80mm wheels that don't put that much torsion on the axles and on these parts of the walls. So this frame is pretty much indestructible. When you go to 100mm wheels, such things become critical. And that's where such things as your weight, for example, start playing a role. I think that personally for me, this frame would still be perfectly fine. And even if I do big jumps, it wouldn't matter much because I am light. But if someone really heavy would skate such frames, this prop might be not enough. If he lands not perfectly straight, but a bit at an angle, these small pieces of metal might be not enough to withstand the impact, and they would just bend or break. Same works for this frame. It has bridges, but of course they don't do miracles. It's still not as strong as if they had just continuous pieces of metal. Or they could have continuous pieces of metal and the bridges, and they would make it even stronger. So again, like this frame, it is quite stiff for my weight, but again, if someone heavier than me would skate it, it might break as well. But as a general rule, yes, your weight is important. So the design of the frame is much less of an issue for you if you are lightweight, but if you're heavy, you really want to go for a strong frame. And probably the last aspect of the frame build quality that I would mention are the axles. The two most common materials are aluminum and steel, and as you can imagine, aluminum is lighter, but it's softer. Steel is much harder material, so it will pretty much serve you for a lifetime, but they are heavier. So if you have 4 wheels, you have 4 pieces like this, they add some substantial amount of weight. So aluminum might be enough. But it's not just the material of the axle that matters, but also the design of it. For example, this is the most user-friendly axle because it comes in one piece. It has a thread on the axle, and then the other part of the thread is in the frame. So they have to work together, the two threads. The other kind of axle is like this. This particular one is for rockering that allows you to shift the wheel up or down. And it has one piece and the other piece. So the thread is part of the axle itself. This kind of axle is of course less user-friendly because you have 2 pieces that you have to keep an eye on when you are rotating the wheels or changing the wheels. You have 2 things instead of 1, and then for full frame it's 8 instead of 4. So you have to put, screw, unscrew. But it gives you an advantage that if something happens to the thread, well, you just buy a new axle, replace it, and your frame is like new. Instead, in a frame like this, you have to rely on this thread a lot. If something goes wrong with this one, your whole frame is screwed. And that's something that happened to me with this frame. As I told you, it is stiff enough for me, but the aluminum itself is still not particularly strong. And I used to tighten my axles really hard because I didn't like the vibrations in the wheels, so I was really cranking it down very hard to fix the wheels really well. And that extra pressure that I was putting on the thread eventually ruined them. And at some point, I think 2 or 3 axles, they broke the threads. So the thread on the axle was strong enough, it was still fine, but the thread in the frame itself, it was destroyed and I couldn't tighten my axles anymore. And yeah, the only way to fix that was drilling the hole, removing that thread completely and replacing the axle with a 2 pieces axle like here. And I actually have a video on my channel where I'm drilling this frame, replacing the axle, so I will put the link in the description. So that is also something to keep in mind. There is a balance between usability and reliability of the frame and the axles. And then the least user-friendly frame in this respect is probably this one that I have, where you can see you have not just an axle made of 2 pieces, but you also have this kind of spacers for rockering, which allow you to then adjust the position of this 2 pieces axle in different directions to create different rockerings. So for every wheel you have 2-piece axles and 2 more spacers. So you can only imagine what kind of mess it creates when you want to rotate your wheels. For each wheel you have 4 pieces of aluminum that then you have to keep track of the rockering, of the orientation of the spacers, and then fit in the axles inside aligned with the wheel. So it's a real mess, but it's also safest option, because if something breaks, I can always just buy a new piece, which is much cheaper than the whole frame. Okay, so I think we have covered the most important things about different frame mounts, different materials, and designs of skate frames. So that should help you to get the one that matches most the style of skating that you want to do and has the properties that you really need from that frame. Probably there are still some things that I forgot to cover, and if that is the case, I will talk about those things in my next afterthoughts video. In the meantime, if there are any things that you would like to comment or ask, or you think that I forgot something, feel free to mention that in the comment section below. For now, thank you for watching this video, and see you in the next one. Cheers!